Welcome to LabMinutes.com and our lab video series in Cisco ASA 1000V. You can find a complete list of ASA 1000V video on our website by clicking on the link above and sign up for our newsletters to receive the latest video update. In this video, we will perform basic configuration on Cisco ASA 1000V in ASDM mode using CLI. This video is a counterpart of SEC0071 ASA 1000V device profile and edge firewall in VNMC mode. And as you will see, there are some configurations that are available on the CLI that you may not be able to find on the VNMC. Here's our lab setup. We have a redundant pair of ASA 1000V installed from the previous video in ASDM mode, with the outside interface sitting on VLAN 128, management interface on VLAN 117, and the inside interface on VXLAN 6010. And we're going to have a test VM sitting on the inside interface that we're going to be using to test DHCP configuration. We're going to use switch 1 loopback interface 172.16.01 as our NTP server. And on server VLAN 32, we have a Syslog and SNMP server at IP.40. And we also have an ACS server at the IP of .100 that we're going to use that to test TACX. So here we are on the console of the ASA 1000V. The first thing we are going to configure is the SSH remote access to the ASA with AAA authentication via TACX to the ACS server in case in your environment you use ACS server for your device management access. So first we need to make sure the ASA has a route to the VLAN 30. So show run route. You can see right now the only route it has is pointing towards the VNMC. So we need to add a route with the command route management. And the subnet is 172.16.30.0/24, and our next hop is 117.1. Okay, then we need to allow SSH access, and specifically coming from the VLAN 32. Via management interface. And we're just going to increase the SSH timeout to maximum, which is 60 minutes, so we don't keep losing our connection due to the session being idle. For the username, just for being a backup in case the ACS server is not reachable, we're just going to make a simple user password Cisco with privilege 15. And then we have to configure a AAA server. TACX name protocol is TACX, and you can see support much more than just TACX. And then you go and do another AAA server command, TACX, and you have to specify the interface that you want the ASA to use to contact the ACS server. And then we specify the IP of the ACS, which is 32.100. Some of the configuration you can do here are things like timeout, how long you want the ASA to wait for the response, authentication response, or reply. So let's just say 5 seconds. And we also need to configure a TACX key, Cisco123. And for TACX, we want to make sure we have the key configured, so I'll create it, generated. So crypto key, my public key RSA. You can see we already have the key, so that's good to go. Now we have to finish off with the AAA authentication command. And first we'll do enable console, and we want that to use TACX first, and then fail to local. Next one is HTTP console TACX first, again local. And then we do SSH console TACX local. And then we also want to make sure you do AAA authorization exec authentication server. Okay. And we also want to make sure the ACS is reachable from the ASA. Let's see, it's pingable. And on the ACS side, the ASA has already been created as a network device with a matching TACX key. So let me show you real quick by logging into the ASA interface. It's ACS admin. Right here under the network resources and network device and AAA clients, and here we have an ASA added as a tenant1-ASA1. Okay, we TACX and they can show the key even. So it's Cisco 123, just like how we have it configured on the ASA. So now everything should be in place. We can go ahead and try to SSH to the ASA. And here we immediately get prompt for to accept the key, public key. And we can just log in. And we already have a user account created on the ACS. So let me show you that also. Under identity storage, we have user called LabMinutes with the password of Cisco. So you can see we can successfully log into that and even enable. You can see we can successfully authenticate the enable as well. Okay, so from now on, let's continue with our configuration from our SSS session here. The next thing we are going to configure is the interface. You can see by default the inside and outside interface is not configured with the IP or anything. So first, let's configure our inside interface, which is Geek00. Give it a name, inside. Security level should be 100 by default, but it doesn't hurt to type that in again. And then IP address is 10.0.1/24. And since we are in a HA pair, we also need to specify the standby IP. Okay, now next we go to the outside interface, give it a name, security, level 0, and then again IP address 128.16 with the standby IP of .17. Okay, now we can try to ping the next hop, which is 128.1. Obviously you have to do no shut. Let me go back and do no shut on the other one too. So show interface IP brief. And now let's try to ping one more time. Okay, you can successfully ping the next hop. Now let's go through some of the generic or global config. So first is password, Cisco, enable password, local Cisco. If you want to locally encrypt all your key and not have it unprotected, so you can do a key config key password encryption, and then you specify the key for the encryption, which is use Cisco, and then to enable AES encryption to your local password, then you do password encryption AES. Okay, just add a security to your password storage. Now let's configure the host name. So we'll call it tenant1, DC1, app1, and ASA1 for the host name. DNS, we're going to enable DNS lookup over management interface, and we can configure DNS server group. Just going to use the default DNS, and our name server is located at the IP of 32.40, and we give a domain name labminutes.com. Okay. Next we set the clock time zone. We are Pacific Standard Time, so it's -8. And then we can also configure summertime if you have a daylight saving. Just do PDT recurring. Next we'll create a NTP server that points to our switch 1 loopback interface, which is 0.1. Get preference. And then we need to make sure we have a route to that IP. And we're going to use the management interface for that. So next hop is 117.1. So make sure we can ping our NTP server, which we can. The next route statement or static route we are going to do is the default route. So route outside 00 with the next hop of 128.1. We can try to ping internet, which we can. Okay, if you want to allow ASDM access, then you want to make sure you enable or configure HTTP allow subnet. For us, it's just VLAN 32 coming in over management interface. Okay, next we'll create or configure banner, MOTD, we're just going to type something like authorized access only. All right. We can also customize our prompt. So right now by default it just show up as a host name. So if you want the ASA role or state, whether it's active or standby, to be part of your prompt, then you can use the command prompt, and then we want to see host name priority being the primary or secondary, and the current state being the active or standby. You can see as soon as you type that in, we now have a designation being a primary and being active for this ASA. Next thing we are going to configure is the SNMP server. And if you remember, if you watch our video on the device profile back in the VNMC mode, there was not really an option to configure SNMP server. Here, you can specify the SNMP server. So host management, we said it's going to be coming from a IP of 32.40. Community Cisco version 2C. Let me kind of expand this since our prompt is getting a little long. And then SNMP server location, just say something like data center. And SNMP server contact, let's say LabMinutes. SNMP community, Cisco, and SNMP server enable traps. Okay. Next item is Syslog server and lockings related command. So first start out with locking enable, and then if you want to timestamp on the other locking, then we do locking timestamp. Then we do locking buffer size to specify your local buffer size. It's going to go with 8192 for now. And then for locking console, let's say we do not want to see all the messages, locking messages in the console, which is going to make it level critical. And for locking monitor, let's make it debug. And locking buffer, we also want debug. So buffer debug. Actually, it's buffered debug. Traps or anything that gets sent to Syslog server, we also want level debug. And finally, we want to specify the Syslog server IP. So locking host, specify interface management 32.40. Okay. Next, we're going to configure the DHCP or make an ASA as a DHCP server. So if you did not have a dedicated DHCP server in your virtual data center environment, then you can certainly use ASA for that purpose. So first, specify a DNS server. So you want to give it 4222. For the domain, just come up with a bogus domain called tenant1.com, and with the starting address of 10.0.128 and to 10.0.1.223, and this is going to be served through an inside interface. And then once you have all those commands configured, you enable it on the inside interface. The last thing we want to look at is the failover configuration, although the majority of the configuration for failover is already there, as we have seen that if you do shell failover, we've got a good state for both primary active and secondary standby. But the benefit of doing the SDM mode or in the CLI, there's additional command that you can do. So if you do show run failover, and again, if you're familiar with the failover configuration already from the physical ASA, you can see these commands are pretty much minimal, and there are actually some additional command you can put in. One of those is failover replication HTTP to make sure the HTTP states are replicated along with the config to the standby unit. And then you can also tweak things like poll time over the interface. You can say we want this as low as 3 seconds and then hold time as low as 15. So the failover detection goes faster. And you can also adjust like a global poll time in a millisecond level of 500, and then hold time again as low as 3 seconds. Okay, so you can see these are pretty much the benefit of doing all these in the command line, because all these commands are available to you, as opposed to when you do it on the VNMC, you can't really see those commands. Alright, so I believe we have pretty much all the basic config that we need at this point. Configure on the ASA. I think we test the ping test to the internet already, so let's try one more time anyway. Alright, next let me bring up the Syslog server. Just make sure the syslogging is working. You can see as I jump in and out of the config mode, we're getting log messages on our Syslog server. So we know Syslog is working. Next, we're going to test SNMP, and we have a program called SNMPB that we can use as the poller here. And I believe I already have the ASA added, but just to show you, this is the management IP on our ASA 1000V 117.16, and we specify as a version 2, and then we provide a read community of Cisco. So what we can do, we can go ahead and expand the MIPS and just pick the one like system, and then just perform a SNMP walk. And here, some of the information that we got back from polling is the device being ASA version 8714, contact is LabMinutes, and location is data center, and these are all the information that we provided as part of the SNMP server command. Okay, so SNMP is working as well. The last thing that we need to verify is the DHCP, and I said that we have a host sitting behind the ASA, so let me bring that up so we can test the DHCP. Actually, what we can do right now, we can do show DHCPD bind, and you can see there's an IP that's been given out by the ASA, and that's the 1.128, and I believe that is our host right here. Okay, so let me go ahead and log in and just verify that the host has been assigned the correct IP, default gateway, and DNS server. Okay, let's bring up the command line. Then IP config all. Here we scroll up. You can see the IP of the host is 10.0.128 with the default gateway of 1.1, and the DNS server is 4222. So we should at least be able to ping the default gateway, ping 10.0.1.1. So at this point, we're pretty much done with the global configuration of the ASA as well as some of the management related configuration. The next thing we're going to look at is the configuration that will treat the traffic that goes through the ASA. Okay, so that wraps up our video on ASA 1000V basic device configuration in SDM mode using CLI. You can visit our website to view an extensive list of our lab videos and sign up to get access to additional lab contents. Thank you for watching LabMinutes.com, and I'll see you guys in the next video.